All right, so we're in section 10.4, talking about hyperbolas. And I'll grab the note sheets in just a second. I just want to talk a little bit about hyperbolas, and then we'll get the notes onto the note sheet. So one important thing about today's lesson, it's the last lecture that we're ever going to have. So after this, we review for our test, we work on our project, and we review for the final. So this is the last material that we're learning. All right. So you can put this on your note sheet, just somewhere in the margins, just this little bit of information. So hyperbola is, listen up guys, hyperbola is a conic section. Which means that we can make hyperbolas by cutting a cone. And we get a hyperbola by cutting a cone parallel to the axis. So we're cutting our cone by a plane parallel to the axis. So a couple of things to notice about a hyperbola is we always get two pieces. So we get a piece on the top part of the cone and on the bottom part of the cone. We cut it by a plane, we get two pieces. So a hyperbola is different than our other conic sections in that there are two parts. So a parabola we had one part, an ellipse we had one part. With hyperbolas we have two parts. Now up in the upper right hand side it says a hyperbola is a plane curve generated so that a point so moving that what you should put in the blank there is the difference. So let me grab that sheet so I have that. So you have your picture of your hyperbola there, and we'll grab that. Grab this. So to make a hyperbola, we can cut a cone, but the way that we're going to work with it, the way we did with ellipses and parabolas, is we're going to talk about a focus, and we're going to talk about a vertex, and that kind of thing. So our point when we move, the difference of the distances from two fixed points is a constant, and we call our fixed points the foci. So if I draw a hyperbola, here's my hyperbola. There's my axes, and my hyperbola will do like so. So there are my two pieces of my hyperbola. And we have a focus here. And we have a focus over here. And what we're going to do with the hyperbola is we're going to say what this is telling us here is that if I look at this distance and this distance, so here's a point on my hyperbola, and I call this one D1 and this one D2. This is telling us that D1 minus D2, those two distances, if I subtract one from the other, I get a constant. So with an ellipse, I added the two distances and I got a constant. With a parabola, the distance from the focus to the directrix, if I added those two distances, those were the same. They were equal. So this is how we're going to work with hyperbolas. So let me grab the other picture, and we'll start filling in our information about the equations of hyperbolas. So this is what a hyperbola is. We have these two foci. We have these two distances. Oh. And if we subtract those distances, we get a constant. So this is what you have on the right side of your sheet there. I'm sorry, the left side of your sheet. Our horizontal hyperbola. So a couple of important things on our hyperbola, like with our other shapes. We have a focus inside each branch of the hyperbola. We have a vertex for each branch of the hyperbola. And we have a center for the hyperbola. The center is halfway between the two vertices, halfway between the two foci. So this is our center. For a horizontal hyperbola, our equation for a horizontal hyperbola x minus h squared over a squared minus y minus k squared over b squared equals 1. So right off, the difference between a hyperbola and an ellipse, they look almost exactly the same. Hyperbola has a minus sign here rather than a plus. So that's what makes it different than an ellipse. We have a minus sign rather than a plus. Our center, just like the other shapes, our center is at the point HK. So this tells us, H and the K tell us where the center is. The transverse vertices. The transverse vertices means the vertices that are on the same line as the focus. We call those the transverse vertices. Just like with an ellipse, A, the number A tells us how far to the left and the right of the center we're moving to get to the vertices. So our transverse vertices are H plus or minus A, K. So we're moving to the left and the right of the center by A units to get to our transverse vertices. And that's these 2 points here. The conjugate vertices aren't actually on the hyperbola. That's this point up here. So that's going to be a conjugate vertex. That's going to be that point. This point down here would be a conjugate vertex also. The conjugate vertices, B, tells us how far up and down from the center we need to move to get to our conjugate vertices. So that's going to be H, K plus or minus B. So I'm moving up or down B units from the center to get to the conjugate vertices. We never talked about the eccentricity of an ellipse. We'll talk about it again at the end today. But the eccentricity is, we call it E equals C over A. And the eccentricity tells us how wide or narrow our hyperbola is. And for a hyperbola, it is greater than 1. The hyperbola has 2 asymptotes. So we have these slanted asymptotes. Our asymptotes for a horizontal hyperbola, y equals plus or minus b over a x minus h. But we'll find them a little easier way. To find our asymptotes, what we're going to do is draw this little box here. The length of this side of the box is 2a. I'm going over to the vertex and over to the vertex, so that side of the box is 2a. And the length of this side of the box is 2b. So we're going to draw this little box in here in the middle of the hyperbolas, and the asymptotes go through the corner of the box. Our foci, here and here, C, just like with the ellipse, C tells us how far to the left and the right to move from the center to get to the foci. So my foci are going to be H plus or minus C. Okay. So A tells us about the vertices, B tells us about the conjugate vertices, C tells us about the foci. And for an ellipse, c squared equals a squared plus b squared. Sorry, for a hyperbola. For all hyperbolas, c squared equals a squared plus b squared. So it's a little different than with an ellipse. With an ellipse, we had a squared equals c squared plus b squared. So it's a little different. So our equation looks very similar to an ellipse. We just have a minus sign. And the center, we find the center the same way. And again, A tells us how far to move from the center to get to the vertices. B tells us how far to get to the conjugate vertices. And C tells us how far from the center we need to go to get to the foci. All right, let's look at the vertical ellipse. Or sorry, vertical hyperbola. All right, so there's the right side of your note sheet. So for a vertical hyperbola, a hyperbola opens up and down rather than side to side. So our equation is going to look almost exactly the same, except the part with the minus sign switches. So we're going to get y minus k squared over a squared minus x minus h squared over b squared equals 1. And over here to the right, for both types of hyperbolas, a is always under the positive part. So when you look at your equation, the number that is under the positive part is a squared. The number that's under the negative part is b squared, always, no matter which way your hyperbola is pointing.
Will there always be a positive and a negative?
For a hyperbola, one is always positive and one is always negative. If they're both positive, then you have an ellipse. And we can tell if it's vertical or horizontal depending on which part is positive. So here the y is positive, so we have a vertical hyperbola. On the last one, the x was positive, so we have a horizontal hyperbola. So if x is positive, that tells us we have horizontal. If y is positive, we have a vertical hyperbola. We find the center the same way. Our center here is just h, okay? Our transverse vertices, those are what we call the vertex. The transverse vertices, A tells us how far from the center to move to get to the transverse vertices. With a vertical hyperbola, we move up and down from the center. So the transverse vertices are going to be h, k plus or minus a. So we're moving up and down from our center. The conjugate vertices, that's here on the edge of our little box. We're moving left and right from our center. And that b tells us how far to move left and right. So h plus or minus b. Okay. The eccentricity is still c over a, and it's bigger than 1 for a hyperbola. The equations of our asymptotes, k plus or minus a over b, x minus h. But really what we're going to do with the asymptotes, we're just going to sketch our asymptotes, and we'll just sketch this little box. The length of this side of the box is 2a. The length of this side of the box is 2b. So we'll sketch that little box in between our two branches of our hyperbola and draw the asymptotes between the corners of the box. The foci, C tells us how far from the center to move to get to the foci. So our foci here, we're moving up and down from the center. So our foci are going to be h, k plus or minus c. We're moving up and down from the center to get to the foci for a vertical hyperbola. And again, for all hyperbolas, c squared equals a squared plus b squared. So with the conic sections, the important thing to remember is what our letters, what this A, B, and C are telling us about hyperbolas and about ellipses, and what P is telling us about parabolas. A, B, and C with ellipses and hyperbolas tell us how far to move to get to the axes, to get to the vertices. That's what A tells us. B tells us how far to get to the conjugate vertices or the co-vertices. And C tells us how far we move from the center to get to the foci. For a parabola, P tells us how far to move from the vertex to get to the foci and the director, the focus and the directors. So that's really the key to these conic sections, is remembering what all these pieces tell us about the shape of them. All right, so let's finish the bottom of that front page. It says distances. So let me grab that part. So that's what I was just talking about, our distances from the center to the transverse vertex. A tells us how far from the center to the transverse vertex. A always tells us how far to get from the center we need to move to get to the transverse vertex. B always tells us how far we need to move from the center to the conjugate vertex. And C tells us how far we need to move from the center to get to the foci for each type of hyperbola. And this is the same for ellipses. These numbers tell us the same things about ellipses. All right, so questions so far about ellipses, or sorry, about hyperbolas.
So the transverse vertex is the one on the actual parabola and the conjugate is...
Yes, the transverse vertex is the one that's actually on the hyperbola. The conjugate vertex is what we're going to use to draw the little box so we can figure out our asymptotes. All right, so let's do a couple of examples with these hyperbolas. Let me grab my other sheet here. I want this one. So we're going to work through this first example. This is the kind of problem that you'll be asked to solve with hyperbolas. Looks just like the questions you were asked to solve with parabolas and ellipses on the quiz. So we want to find the equation and sketch a graph. So when you have a problem like this, what I'm going to suggest is that you start making your sketch. So this tells us that the foci are at -1, 2, -1, 2. Let me make that in red. And 5, 2.
Wait, how do you know which vertices they're talking about?
When they say vertices, they mean the transverse vertices,
Okay.
the ones that are actually on the ellipse. So there are my two foci, at -1, 2, and at 5, 2. So what do we know right away? Which orientation, is this a vertical or a horizontal hyperbola? It has to be horizontal because these are on, the foci are on the axis. So we know right away that this is a horizontal. So we know that the x part is going to be positive and that the a is going to go underneath our x. All right, it says our vertices are at 0, 2, and 4, 2. So here is 0, 2 and 4, 2. So there are vertices. From this information, what is our center? Where is our center going to be? The center has to be halfway between these points. So the center is halfway between the foci or halfway between the vertices. So our center has to be at the point 2, 2. So there's our center. Well, now we have all of our numbers. So the distance from the center to the vertices is A. So how far is the center from the vertex?
2.
2. So A equals 2. Center to the vertex, 2 units. The center to the foci. C has to be 3. The center is 3 units from the foci. We could just count count squares here. 1, 2, 3. And we know that c squared equals a squared plus b squared. So we can figure out b. So we have 9 c squared equals 4 plus b squared. So b squared equals 5. And b equals the square root of 5, which is about 2.2. So there are my distances. Now I'm ready to write my equation. We know that it's horizontal, so we know the x part is positive. So I'm going to say x minus the x coordinate of the center, x minus 2 squared, or sorry, x minus 2 quantity squared over a squared. A squared always goes under the positive part, minus y minus 2 squared over b squared equals 1. There's my equation. Now to sketch a graph, what we're going to do is we're going to draw a little box between the two vertices, and we're going to go up and down to the conjugate vertices from the center, 2.2 units. I'm going to go up 2.2 units here, whoops, from the center, about 2.2 units, just a little more than 2, down a little more than 2, and I'm going to draw this little box in here. My asymptotes are connected through the corners of the boxes. So I'll draw my asymptotes. There's one asymptote. Go through the corners of that box. And the size of the box tells us how wide our parabola is going to be. Oops, not very good there. And then I'm just going to sketch the hyperbola between those asymptotes. And the, no. We could substitute y equals 0 in here and find where it crosses the x-axis. But to sketch your hyperbola, what you want to do is draw that little box by finding the transverse vertices, connect the two vertices and the transverse vertices with the little box, and sketch your asymptotes between the corners. And that tells you how wide or how narrow your hyperbola is going to be. So questions on what we did here? A, again, tells us how far we move from the center to the vertices. B tells us how far we move from the center to the conjugate vertices. C tells us how far we move from the center to the foci. All right, let's do the second example there. All right, so here we have this equation. We're doing the same problem. We want to find the center, the vertices, the foci, and the equation of the asymptotes. So for this type of problem, we just have this long equation. What are we going to have to do? What do we do when we have this kind of thing with an ellipse? We have to complete the square. twice. So I have to complete the square on the x part and complete the square on the right part. So we're going to separate these into we're going to separate the x's and the y's and put the number on the other side. So I'm going to write 4x squared plus 8x minus 3y squared. And my numbers are on the other side. Subtract 16 from both sides equals minus 16. Well, this one is nice because I only have this 3y squared, so I don't really have to complete the square here. I only have to complete the square on the red part. So the first thing I'm going to do is factor out this 4. And then I have minus 3y squared, and I'm just rewriting this, equals minus 16. Now I'm going to complete the square here. So I have 4x squared plus b is 2. b over 2, 2 divided by 2 is 1. 1 squared is 1. So that completes the square there. Minus 3y squared equals, I am multiplying this 1 by 4. I have to distribute that 4. So I'm multiplying this side, I'm adding 4 to this side. So I'm going to add 4 to the other side to keep my equation the same. I'm going to write this as 4 times x plus 1 squared minus 3y squared equals negative 16 plus 4 is negative 12. Almost have the equation now. My equation for a hyperbola has a 1 on the right hand side. So I'm going to divide everything by 12. Oh, sorry, negative 12. So 4 divided by negative 12 is negative 1/3. Tw 3 divided by 12 is negative 1/4. Or sorry, positive 1/4, and I get equals 1. Yeah, right there on your phone. So there's my equation. And I'm going to rearrange it to write it in the form that we had before. Y squared over 4 minus x plus 1 squared over 3 equals 1. So looking at this equation, is this going to be vertical or horizontal? The y is positive, so this is going to be vertical. So I have a vertical axis. The A number we always find under the positive part. So what is A going to be? We have 4 under the positive part, so this is A squared. This is B squared. So A squared is 4, so A equals 2. B equals the square root of 3. And C squared equals A squared plus B squared. So C squared equals 4 plus 3, or 7. B is square root of 3, so B squared is 3. So C squared equals 7, and C equals the square root of 7. All right, now we're ready to start sketching. Where is the center of this hyperbola? Negative 1, 0. This gives me the x-coordinate. This gives me the y-coordinate. So the center is negative 1, 0. So I find my center over negative 1. There's my center. We know it's a vertical hyperbola. So A tells us how far to move up and down to get to the vertices. So I'm going to move up and down by 2 units from the center to get to my vertices. I go here. And here. So the vertices are -1, 2, and -1, -2. Moving up and down by 2 units. C tells me how far I need to move to get to my foci. So the foci, I move up and down by the square root of 7 units. So let's approximate the square root of 7, plug that into my calculator. Don't know that one off the top of my head. So the square root of 7 is about 2.6. So I'm going to move up and down by 2.6 units to get to the foci. So I'm going to be at -1, 2.6, and -1, -2.6. So my foci are just a little further up and down from my vertices. So the foci are right inside the vertices. And the conjugate vertices I'm going to move left and right by B units. Square root of 3. Square root of 3 is about 1.7. So I'm going to move over about 1.7 units to get to my conjugate vertices. So my conjugate vertices, I'm moving left and right from my center. So I'm moving, I'm going to be at -2.70, and if I go 1.7 here, I'm going to be at 0.70. So there's my vertices, conjugate vertices. To sketch my hyperbola, I'm going to draw that little box. Drawing the asymptotes. I'm just going to sketch it in by hand here between the corners. And then there is my sketch of my hyperbola. Thank you. So we're all set with that one. Any questions on that example? So those are the kinds of problems. Those are the kinds of problems that you're going to have to solve using hyperbolas. Now let me talk really quickly. There's one other thing that we need to do for the very end of the chapter. One other type of problem. So let me grab the sheet, the additional notes. I don't need to grab that. I can just go back. So we said for an ellipse or a hyperbola, just a reminder, the eccentricity is C over A for either one. For an ellipse, it's going to be less than 1. For a hyperbola, it's going to be bigger than 1. The general equation for a conic section is ax squared plus cy squared plus dx plus ey plus f equals 0. So if we have some kind of equation like this, this is the kind of equation we ended up completing the square on to find our center and all of our other information. By looking at this equation, we can tell if this is a circle, an ellipse, or a hyperbola, or a parabola. If A equals C, we have a circle. So if the number in front of the squared parts are both the same, we have a circle. If A times C equals 0, we have a parabola. And that means only x squared or y squared. We only have one squared thing. If AC is greater than 0, we have an ellipse. That means A and C are either both positive or both negative. And then we only have one option left. If AC is less than 0, we have a hyperbola. And that means with A and C, one positive, one negative. So if we have an equation that looks like this, we can tell right away if it's a circle, parabola, an ellipse, or a hyperbola. So you'll get something that looks like this, some long equation, and it'll say, is this an ellipse, and a circle, a parabola, or a hyperbola? Or it'll give you a choice and say which one is the ellipse. All right, homework. There you go.